Hi everybody, in this video we are going to talk about the odometry. We are going to make all the lines of codes that help us to measure the position of our code. In this video too, we are going to talk about the last video because we found a problem that we have to fix it. The last video we talk about the noises of the measurements, and we could see in this video that this program was like we expect, that we have a little problem that we have to implement the corrections. So let's do it. Please like, share and subscribe to my videos. It helps me to make videos like this. I was checking the last video, I was checking the code, and I found that it works good. You could see that the noises of the measurements are lower than the first time. You could see the great reduce of the noises in the signals. But I have some problem. If you could see that I try in this video, try to reduce the turn of the wheel. But that reduce is make like this part. In this part I reduce the PWM and I try to put some load in the motor until that the motor stop. In this part the motor stop, but you could see that the signal in the video has like the motor has a velocity, and there is a big problem. Why did it happen? I think that our calculation is made based on the ticks. We calculate the delta time between ticks, and that generates our velocity, our speed of the wheels. So if the wheels stops, then it is a problem because it waits the other interruption. If this interruption doesn't work, doesn't appear, that delta time it can be calculated. Then the velocity is still being that the velocity that has in the last iteration. So the wheel have like a velocity in the program, but in the real life is stopped, and there is a big problem. The only way to find a solution is to try to make a good coffee, take a coffee and think about the problem. Really, I think a lot about this problem, but finally I found a way to fix it, to make it right. At least I think that. If you have another solution, let me know it. The first thing that I did is try to watch what is the time between ticks, what is the maximum time between ticks. That is the delta time of the interruptions. And I saw I let the wheel turn around a speed around like 30 PWM signal. There is a really slow velocity of the wheel. That is the maximum time. But if you try to stop it, the wheel, you could see that the wheel this time is incremented around 250 milliseconds, and that is the maximum time that we have to use to calculate the minimum velocity of our wheel. So I put two if in the while loop. Is that if is compared with the delta muestreo interrupción, that is the delta time between ticks. If this delta time between ticks is higher than 200 multiplies by the number of the ticks, that is the number of the filter, you could send the signal to zero, the frequency to zero, that lets that the velocity of the wheels make us 0 too. And that's it. You could see that in this part you could see that the wheel is turning, but if I put my hand in over the wheel and the wheel stop it, that velocity of the wheel goes to 0. And that is our solution. That is the thing that we want to achieve to our car. And that's it. And you could see that those if help us to make that the program works like with speed. And that's it. It's a really simple solution, but I was thinking about that. It was an amazing problem. In the other hand, we talk about the sample time. In this part, we are going to implement that. We copy all the variables that we talked in the last time. I create k variable is the time, the sample time that we are going to improve, that going to implement in the code. We generate the first line is the muestreo actual, that is actualizing a variable that is actualizing in every while loop, in every loop of the Arduino. And we generate that delta muestreo, that there is the difference, that variable is the difference between the time, the actual time, and the last time. And if this delta time is higher than k, this is the implementation of our sample time. And the last code, the last line is the time, last time is the equal to the actual time. That is the implementation of the sample time. And finally, those are the lines that we are going to use to implement the odometry. There is the read ticks, there is the ticks, actual ticks, the last ticks, and the delta ticks that is implemented for the right wheel. And the R distance is the distance move for the right wheel. I create the same variable for the left wheel. You could see that only change the R by a L, and that L distance is the distance move for the left wheel. We create a C distance, that is the distance move for the central point. X, G, and Phi are the position and the angular position of our car. And creates another variable that is the longitude, that is the large, the distance between wheels. And we include the library match.h. That library helps us to use a function, a mathematical function, in this implementation. And we defined another variable that is another constant that is very important, p. In this case, the pi is the 3.1450, and that is a really long number, and I defined that variable like pi. And in every interruption function, you could put those lines are ticks equal plus plus is the increment of the right ticks, and in the left encoder we implement this line L tick. That is the implementation of the ticks off in every encoder. In the last part, we implement a function called Odometria. That function is implemented some variable. The first one is delta tick, that is the difference between the error tick, that is the tick, the actual tick of the right wheel, minus the R tick ant, that is the ticks that are counting in the last function. and we calculate the r distance. R distance is a formula, is an equation that we explained in the last video. In this case, is p by distance by delta tick over 20. That 20 is the number of the ticks that you are going to have. In this case, in my case, is 20 ticks. The same lines of codes, if by the left wheel we make the same calculations, but you could see that all the variables are for the left wheel, and those variables are calculated similar. L distance and R distance are the distance record, is the distance moved for each wheel. In the other part, we calculate the distance of the point, the central point of the middle point. That is the promedium between the R distance plus the L distance over 2. There is a mean. And we calculate the position with this C distance. You could calculate the position X and Y. There is X plus the C distance by cos of phi, and Y position is similar to the other equation, that is Y plus C distance by sin of phi. That is the equation, is really simple. And the other equation is the equation that measures the position of the robot, that is phi plus the R distance minus L distance over the longitude, que is the distance between wheels. And this line next, the next line is phi is equal to a tan 2 sine of phi cos of phi. That line is really important because we have to improve, we have to make that the phi angle goes between limits. Those limits are pi and minus pi, that help us to to improve that our controller understand good the angles of our car. In other hand, it can't handle those angles. In the last lines of codes, the both last codes, little codes, is the actualization, the actualize of the before ticks, the R tick anterior. And in the body loop, we aggregate, we add the function odometria. In this part is called that function, and that's it. Is really simple to make it. Those are the lines that we use to try to measure the position of our car. Is really simple to make it, and that is everything for us. We implement in this video a solution for the filter, a solution for the sample time, and the last thing is the odometry by our car, that is the measurement of the position. And I think that is okay. Everything right here is okay. I think that you understand it. If you don't, really let me in the comments. I really try to understand you. I really like if you enjoyed this video. Thank you so much. Please like it.